Hi everyone. Uh, After we perform experiment for tuning the best performing models and feature extractions, here we came to assemble learning. In experiment 3, we will experiment on the base algorithm that we have chosen and perform the ensemble learning to examine the model performance can be improved or not. So same as the previous experiments, so we have applied the same algorithm as best model, which are support vector machines, SVM, can nearest neighbor, KNN, and also logistic regression, LR. So by using, we are also using the default parameter for each of them to allow us to compare the performance before and after performing the ensemble learning. Hence, we can know our model have improved the accuracy or not after applying the ensemble learning. There's four type of ensemble learning we have chosen. So the first one will be the bagging. Bagging in ensemble learning involves training multiple models on different bootstrap samples of the data and also aggregating their prediction to improve the robustness and reduce the variance. So there's three parameter we have tuned for bagging, which are n estimator. N estimator is the number of base estimator in the ensemble, and also max samples is the number of samples to draw from X to train each estimator, and also the last one is a max feature. So max feature actually is the number of feature to draw from X to train each base estimator. The second example learning we are using is wording. So it's a technique where multiple models, for example, classifier or regressor, are trained independently on the same data, and their prediction are combined using a voting mechanism. For example, the majority voting for the classification or averaging for the regressions used to make the final predictions. So for the parameter we have tuned, right? So we have the estimator. So estimator will include the all the different type of model we wanted to fit into the voting classifier, and the voting parameter, if you have the hard and the soft, we can use to tune. So if I using the hard as a value, so it use the predicted class label for the majority rules voting, and else if soft predict, right, so the class label will based on the sum of the predicted probability, which is recommended for an assembler of well calibrated classifier. The third ensemble learning we have choose is the boosting, and we choose adaptive boosting. And adaptive boosting actually sequentially train the weak model on the weighted version of data, and also combine their prediction to focus on difficult instance and improve the overall accuracy. So we also tune the parameter for adaptive boosting with the n estimator and also the learning rate. So the last ensemble learning we are choosing is the stacking. So it involves the training multiple diverse base model using the prediction as input to a meta model, and then use it to make the final decision. So it's aimed to leverage the strength of the different models to improve the performance, and we have included the best estimator with our base model, base algorithm, and also the final estimator. We are choosing the logistic regression and also the random forest. After tuning the models, so we did find the best parameter for each of them and include the data in the table so we can able to compare the performance between each of them. So as highlighted the highlighted column, so we can know that stacking is the best parameter referring to the highest recall as the performance metrics we choose. After we find out the best model, which is stacking, so now we include together with other best model to compare the performance. So based on the highlighted column, the performance this increase after apply the ensemble learning.